right?
Well, it's kind of like how people used to not want to use your credit cards online, but some of your other doctors do because they didn't worry about it as much. It seems like it improves it just from a, like you're saying, trust perspective. But it doesn't seem like it would change the way the application would work, aside from you just doing that.
So what's critical for blockchain adoption is really user density, right? The internet really didn't take off until, right, everybody was using email, right? Because then everybody was on the internet, everybody was using it, and then it became, easier to use these like foreign applications, the web browser and everything, right? So once there were enough people using it, that's when the breakthrough comes. So it's going to be simple. Similarly, along the same vein, once you have enough user density, that's why. I'll give you one example, and that's actually coming back to insurance, right? Even though now I'm talking about health insurance for a second. May I? Right? Even though that's maybe you're more P&C, but let's say so in healthcare, right? One of a huge problem is provider, i.e. the data of your doctor, and that is being accurate and up to date, right? For hospitals, for the licensing bodies, for the health insurance companies. In fact, there is a requirement, a HIPAA requirement now, that the health insurance companies need to reach out to their providers that are working with them to make sure that the data is. That's a huge pain in the butt.
How does blockchain limit certain regulations as far as data storage?
Bear with me for a second, right? So what's important here, right, is that everybody has a big problem. It's a problem for the providers. It's a problem for the regulators. It's a problem for the hospitals. It's a problem for the health insurance companies, right? So now if you invert the problem and saying it's actually in the interest of the provider to provide accurate data. So why don't we turn it around and saying, you're making the claim, these are my office hours. Oh, and by the way, I take Aetna and Cigna. I have a relationship with them. Okay? What if, right, Aetna and Cigna, you put that and you publish that out through blockchain, and Aetna and Cigna would get a notification saying, hey, Dr. Freund made the claim that he's working with you. Is that actually accurate? And here's his data. The nice thing about this problem is it's all public data, right? So whether you're an oncologist, whether you're licensed in the state of Maryland, is all public, right? By law, right? What you can do now is you can use the provenance that's provided by blockchain and say, he made this claim. If Cigna says, yes, that's true, you can record that on the blockchain and everybody can see it and says, yes, this provider, right, is actually working with Cigna, right? And it is on the provider to update that. Why? Because accurate data is now becoming his reputation, right? And we're working with a couple of payers that are saying, well, if you don't update your data, right, in such a manner, right, that we're validating whenever it changes, this will be updated. Then we're not going to pay you, right? So, and the nice thing about, because it's decentralized, right, everybody controls their own piece of the pie rather than trying to put everything together in one place and trying to then validate, is this still, everybody has to do their own homework and work together in an ecosystem. And that's exactly why blockchain is so great, because it allows the ecosystem to work together. In insurance, that's critical, right? Because it now allows a whole lot of the friction that currently exists in all the silos, the data silos, just to simply go away. Because what you're putting on the blockchain, in fact, are very simple statements. They're very, very short. It doesn't use a whole lot of data, right? But, and that comes back to user density. Once you get people to adopt these decentralized provider registries state by state, right? And we're working with a couple of states to actually do that. You suddenly move a whole lot of people on the blockchain, and you start to create experiences that are like, hey, this is actually pretty cool. Oh my, wow, I can now get actually paid when the guy leaves the office. Hey, I'm all for that, right? Because now I can now go and say, well, I did this procedure right away. You can check it whether that's covered by the policy automatically. I mean, there are some exceptions, obviously, but most of the stuff you can do immediate real-time payment for the work that was done the same day, because you have all participants signing off. Yes, this is right, and it's recorded on the blockchain for audit purposes, and you're good.
Yeah. So if we're saying that one of the incentives for big companies, right, to adopt blockchain is some sort of reduction of cost. Usually we talk about transactions, and I'm trying to move away from Bitcoin and cryptocurrency. And somewhere over there at the end raised a good point that actually now everyone is going to have huge sizes of storage, because they need to have this. They are a node,
Right.
They need to have that chain of different blocks, so they need to have a duplication of the entire network.
You don't actually need that much. So for example, for Ethereum, and just to keep with a common example, or for a particular type of blockchain, right? You can, again, go lighten the load and archive data, right? That you don't need for validation purposes. And I don't want to go into I'm happy to talk about technical details. Just like, trust me, it's doable, and we're working on that right now, because it is a problem. The Ethereum blockchain is over 100 gigabytes right now, and that becomes rightfully a storage issue. But you don't need to do that if you're segmenting the blockchains. If you're keeping them local, right? Again, why do I need to keep all the data for something that happened in LA over in Germany? Not really necessary. So if you don't need a global chain. You need lots of local chains that when they need to communicate with each other, there's proof that, hey, this chain did everything right, and yes, I trust it because it conformed to the same type of protocol, this interoperability protocol.
Do you say that there's like a master chain that verifies like a root chain, so that like if the root can trust
There
that
is a
chain,
concept from my friends at Tendermint with Cosmos that has such a concept, is actually not required, right? So we're working on something where we have so Ethereum wants to go down and do a logical, try to parallel process in shards, as it's called, in chunks, right? Logically, and we're saying, yeah, but it's probably more efficient to just do what the web companies do and just go wide and just add servers, right? So why can't we run a million blockchains in parallel, right? Yes?
So what if you wanted to take different products in insurance from different companies,
Right.
and put them into your own blockchain, create your own block, your own whatever
Private
you call it.
block.
Can you do that? Could you go and just kind of be a collector of, I want homeowners here, I want auto, I want commercial, I want trucking, and actually put it into, whatever, and I want to put it into my own little blockchain, and
Sure.
all these companies have to contribute to that space?
Yes, those are what's called private blockchains, right? There is a question of how much sense a blockchain makes when it's sitting behind a firewall. But let's just say for some use cases such as this, it actually makes sense to not have it on Ethereum or Bitcoin or some other, but have your own purpose-built blockchain, right? As long as you can connect it back, if you need to, back to a public chain. Or it could be a public chain, but it's permissioned, right? It's like Facebook, right? Facebook is public, everybody can join, right? But you need an account, right? So you have to create an account, you have to enter your information and email address and stuff like that, phone number for recovery. So you're giving yourself already a lot of identifiable information. So think of it this way, that you could create a blockchain that is public, it's open to anyone, but they have to go through a KYC process in order to participate, right? So that is possible, and in fact, we're encouraging our clients to go that way, because if you run a blockchain behind a firewall, you might just use a shared database. That's replicated. It's much more efficient. Your guess?
Hi. Do you have examples of any insurance companies that are running this, or are you pitching a theoretical idea at this point?
Do we have any?
Good question.
Very good question. Do we have any large companies that are actually doing it in production, live? The answer to that is no. You can USAA. You can see your Bitcoin holdings in your USAA account. They did that. So companies like USAA and AXA are very, very active, and they're actively running proof of concepts and pilots in this space to really understand what works, what doesn't, and they work with other companies. And there's actually a blockchain consortium for insurance, which is called B3I.
Actually, fintech are a little bit more advanced on that, and they are trying to, they're using that
B3I.
for internal
B3I.
transactions.
It's AXA, Gen Re,
$12 billion in savings.
right. So they work with chain that I think is the startup that they're working with.
I think the guy over there.
What is the value of blockchain as a whole, and I guess some of the cryptocurrencies that are associated with blockchain being changed as regulations are imposed on blockchains throughout the world?
That is a very good question and a very difficult question to answer. Because, I don't know, some countries will prohibit them, like Ecuador. Others will encourage them. Others will run their own cryptocurrencies. They will create their own blockchains. They will issue crypto US dollar, crypto pound, crypto ruble. There is Estonia is a great example that runs that uses blockchain for their federal services. So everybody every Estonian has an ID card with data that is backed up onto and recorded on a blockchain. So you can prove it this way. So you can prove access right to government services this way. They have a health. They also now have run their health services on that, so they're onboarding more and more services over time. Sweden is just moving their land titling onto blockchain. Cook County just did a pilot for that as well. Switzerland, the canton of Zug, wants to introduce a blockchain-based digital identity for its citizens next year. So yes.
Question, just for my own clarity, is the genesis of every blockchain a unique equation?
It is a unique protocol. It is a unique, yeah. If you want, you can express it as formulas in computer science term. It's a combination of formulas that, when expressed in code, make that system work.
So just try to get a better understanding of blockchain technology in a more practical or real-world scenario. Say, for example, like in Puerto Rico, they found out that a lot of doctors were fabricating these false documents So a lot of people get disability claims approved by Social Security. They found out and they went and they closed it out. How can blockchain prevent that type of fraudulent activity? Because the implication of blockchain is that it's trusted, but if people are maliciously putting false information into the blockchain, I don't see how that can
So
be
it's a
prevented.
different type of trust. The trust there is that when you have the network and you have the nodes, no one can actually go in and sabotage or fraudulent that, unless they do the 51% attack, which means the network, yeah.
But if you add fraudulent data to the blockchain, it becomes part of the chain, and then
Yes.
there's no way to get rid of it.
That's what I'm saying.
Yes. That's
So
his point. It's
which is okay, right? I mean, it's not okay that it's
Yeah.
fraudulent, right? But imagine the following scenario, right? It's like you have a doctor and a patient,
Right.
they're colluding, right?
Right.
And let's say it's found out, right? That transaction is the fraudulent transaction now can serve as proof that these two identities that are on the blockchain, right? And if it's are now flagged as not being trustworthy. And here's the proof, right? So hey, next time that guy files a claim, I'll just say no, right? Or well, we need another independent validator to check that and validate that that's actually true, right? So there can be then additional layers of trust or additional layers of validation that can be added to that, right? So you need, it's with every computer system, garbage in, garbage out, right? But the nice thing about the blockchain is the garbage stays on, and that might be, why is that good? The good thing is, like, if it's fraudulent, right, it stays on it. That's why for criminals, using Bitcoin is about the dumbest thing you can possibly do. Because every single transaction stays on that, right? And once you can correlate, oh wait, this address and these transactions, these guys, boom, boom. I mean, how do you think they found the Silk Road guy? Right? So it becomes dangerous.
But how do you protect against, malicious people wanting to create false narratives about certain people in that regard? So, for instance, if you want to create a fraudulent story or fraudulent narrative about somebody who's on the chain, how could someone with malicious intent not start creating that?
Well, you can say, is that claim, is that true? Who else makes that claim, right? And what is the verifiable data that backs that up? Right?
Basically, you cannot. In terms of the technology itself, you cannot do that. You need to add protection layers about the information that gets into the blockchain.
Right.
The
So-
moment that the lie or the fraud is already in the blockchain, it's true. Later on, you can query that. Yeah, man. Yeah. Wait 1 second.
You can ask, what is cold storage and why would you use it?
Let me repeat the question. What is cold storage and why would you use it? It's a little tangent. It's everything in cryptography is based on what's called a private key. It's like your cryptographic social security number. It's supposed to be unique. But boy, if you lose that, you lose all your Bitcoin, you lose all your Ether, all of that is gone because you can never sign a transaction, which you need to do, digitally sign that transaction, and you need that private key in order to do that. So what do? In order that you might lose it on your, someone might hack it or you might lose it for whatever reason, you put that private key on a hard drive effectively.
Or USB drive?
Or a USB drive. Or you write it down on a piece of paper.
Write it on a piece of paper.
Write it on a piece of paper. At that moment, it becomes cold storage. Cold storage means you cannot directly, it's no longer online. That's it. So any sensitive data you don't want to be online, you put into cold storage, which means in the simplest case you write it, or as some have done it, put it up into a satellite. I kid you not.
No, thank you. That brings up an issue, like, it's one thing that if I lost Ether, I'm like, oh, sad, I lost all that money. But if this becomes like your citizenship, what if you needed your private key to get medical attention from a socialized medicine system and you lose the key? How do you then prove
Right.
that
So you need
still have
you
that
need
right?
to have a good
He's not the owner
Or
of that
your
key.
own
key.
Citizenship is owned by the government, so they're keeping his key in some way, I assume.
No, you
Or
will not.
they have a shared
This is just
key.
hypothetical, really.
Right. So actually, it's not hypothetical.
Except for that one thing.
So we actually have built a digital identity platform, right? And it addresses exactly that problem. How can you recover an identity once it has been compromised? Because that's a real problem, right? I mean, you can be kidnapped, and there are 50 million scenarios, right? So, and it's let's just say there is a solution for that, and the solution is only part technology.